All right, welcome to the Explainer. Every time you shop online, use an app, there's this secret world of communication happening just behind the scenes. And today, we're going to pull back the curtain on one of its most important players, RabbitMQ, the internet's invisible postmaster.
I mean, think about it. You click buy and boom, a whole chain reaction kicks off. Your order is confirmed, your payment gets processed, the warehouse updates its inventory, a shipping label gets printed. How do all these different systems talk to each other so fast and so flawlessly without ever dropping the ball? Well, that's the puzzle we're going to solve today. So, here's the game plan. We'll start by understanding the core communication problem that modern apps are up against. Then we'll meet our solution, this digital postmaster, and we'll actually trace the journey of a single message from start to finish. After that, we'll get into its superpowers, see how it stacks up against the competition, and wrap it all up with the final takeaway.
Okay, so first things first, let's talk about the fundamental challenge here. It wasn't that long ago that big applications were built as just one giant piece of code, a monolith. But today, it's totally different. They're more like a team of specialists, dozens, sometimes hundreds, of smaller services that all need to communicate perfectly to get anything done. Just imagine if your payment service had to call the shipping service directly, and that service had to call the inventory service. If any one of those pieces is busy, or maybe it's just offline for a minute for an update, the whole thing just grinds to a halt. The entire chain breaks. This tight connection, what we call coupling, is just a recipe for disaster. It's fragile, it's inefficient, and it's exactly why we need a smarter way to do things. And lucky for us, there is. Instead of letting all our different services just shout at each other directly and hope for the best, we can bring in a reliable middleman. And this is where our hero, the digital postmaster, steps onto the stage, RabbitMQ. So the official term for RabbitMQ is an open-source message broker. But honestly, the best way to think about it is exactly like a post office. It takes in messages from one application and makes absolutely sure they get delivered safely to another one, even if the recipient isn't home at that exact moment. Basically, it takes care of all the messy logistics of communication, so your apps don't have to worry about it. Okay, so how does this whole digital post office actually work? To really get it, let's follow a single message, a tiny piece of data on its journey, from the second it's created to the moment it's successfully processed. This whole thing really comes down to 4 key players. And you can think of it just like sending a letter, right? You've got the producer, who writes the letter, the exchange, which is like the main sorting office, the queue, which is kind of like the mailbox, and then finally, the consumer, who actually gets the letter. Let's break them down one by one. All right, first up is the producer. This is literally any application that needs to send out some information. In our shopping example, the instant you click that buy button, the website's backend becomes a producer. It whips up a simple message that says something like, order number 123 has been created, and sends it off into the system. Now, here's a key detail. That message doesn't just go straight to where it's needed. Nope, it first lands at the exchange. This is our central sorting facility. The exchange looks at the message, checks its address or its type, kind of like a postal code, and then it uses a set of rules to figure out exactly which mailbox it needs to go into. After the exchange does its thing, the message lands in what's called a queue. And the best way to think of this is like the mail carrier's bag or the actual mailbox itself. It's just a temporary holding area that safely stores messages. And this part is the secret sauce. It means the message can wait patiently, even for hours if it has to, until the recipient is ready for it. This means nothing gets lost just because the recipient is busy. And that brings us to the final piece of the puzzle, the consumer. This is the application that's been waiting for this exact kind of message. So the payment service, for example, acts as a consumer. It reaches into that queue, it picks up our order-created message, and it gets to work processing the transaction. And boom, the journey is complete. Okay, but here's where it gets really clever. The built-in safety net. What happens if that payment service crashes right after it grabs the message, but before it finishes its job? Well, RabbitMQ is smart about this. It waits for what's called an acknowledgement, basically a little signal from the consumer that says, hey, I'm all done and it worked. If RabbitMQ never gets that signal, it just assumes something went wrong and it puts the message right back in the queue to be tried again later. The motto here is no message left behind. You know that whole guaranteed delivery thing? That's just one of RabbitMQ's superpowers. This simple idea of producers, exchanges, and queues unlocks some huge advantages for anyone who's building modern software. When you put it all together, the benefits are just massive. First off, decoupling. This is huge. the payment service has no idea the shipping service even exists. That leads directly to reliability. Because, like we saw, messages don't get lost if one part of the system goes down. And that gives you amazing scalability. Got a Black Friday rush? No problem. Just spin up more consumers to clear that queue faster. On top of all that, you get incredibly flexible routing and support for pretty much any programming language you can imagine. All right, so RabbitMQ sounds pretty awesome, right? But, and there's always a but, it's not the perfect tool for every single job. Like any technology, it has its own strengths and weaknesses, and it's super important to know when to use it and maybe when not to. Okay, so on the plus side, it's obvious. You get that rock-solid, guaranteed delivery we talked about with all kinds of flexible ways to route messages. It's mature, it's well-supported, it's great. But on the flip side, there are trade-offs. It can be a little more complex to set up and manage than some other tools. And if you're dealing with a truly massive fire hose of data, some alternatives might be a bit faster and a little lighter on your system's resources, CPU and memory. So that kind of begs the question, right? Where does RabbitMQ fit in with the other big names you might have heard of? Well, think of it like this. RabbitMQ is your smart, reliable mail sorter. It's for when you absolutely positively need that letter to get delivered. Kafka, on the other hand, that's more like a high-speed data fire hose. It's for when you have a massive, nonstop stream of events. And then you have something like Redis Pub Sub, which is for when you just need to broadcast something super fast and lightweight, and it's not the end of the world if someone misses the message. Okay, so we've covered a lot of ground. What's the one big idea you should walk away with about our digital postmaster? It really just boils down to this. When your system absolutely positively cannot lose a message, and when you need smart, intelligent ways to get those messages to the right places, RabbitMQ is an incredibly powerful and battle-tested choice. At the end of the day, it's all about reliability and flexibility. That's its game. And there you have it. That's our deep dive into RabbitMQ. It's just one of these amazing, totally invisible systems that makes our digital world possible. And it kind of makes you wonder, right? What other secret workhorses are out there, quietly keeping everything running for us? Thanks for sticking with me on this explainer. See you next time.